Good morning everyone, this is Joy Banerjee and you are watching your favorite science YouTube channel, Olpo Sholpo, Take a Golpo. In our previous video, we already see the famous mathematician, Professor Jayant Narlikar, say about what is scientific temper, what is good thing of science, what is the superstitious belief, how to overcome from this superstitious belief and spread the light of the science.
Now if we don't get good logical thinking and the good reasoning, we can't fight with these old customs of superstition. I fought with my grandmother. And I told her, we are not going to do this and this is not correct and this is not even good. So, what I am trying to suggest is, we learn from the science, we use our brain or dimag, and then we can fight with the superstition.
Now in this video, we will see the famous Professor of Astrophysicist, Professor Jayant Vishnu Narlikar, what he says, what his important thinking and his important speech about astrophysics and about astronomy. So, don't waste our time. Let's start the video and see what the Professor Jayant Vishnu Narlikar say about astrophysics. Our beloved Professor Jayant Vishnu Narlikar.
I want to talk about a question which I am asked by many people from time to time, and it can be put in the form, why study astronomy? What is the use of studying astronomy? That is the question that is asked. So this is the frequently asked question. You can see it on the screen. And that astronomy is a subject which is concerned with distant stars and galaxies. So, if that is the case, why should it be relevant to us on the earth? Are we not well separated from all those objects which astronomers are interested in? So, if we actually look at the historical examples, we find that astronomy had helped human societies and cultures. For example, making calendars was based on what the different stars in the sky are and where they are. That allowed you to decide which time of the year it was, and that is how calendars were made. Then when you were doing agriculture, you required suitable timing to tell you when to take the next step in agriculture, and that was based on astronomy. So farmers had to know astronomy at a certain level. Then there were religious rites like the ones you see here. There are many different types of religion and different types of celebrations of special days in different religions. All these are based on astronomical location. And of course, when you are doing navigation across high seas, going very far away from land, you don't know which direction you are going. And at that time, the stars come to help you. So this is another example, navigation. So we can say that those were the earlier usages. What about today? What astronomy gives us that is very important. So first of all, I will tell you something that you may not find it plausible, but I will give you the whole argument, then you will see that what I am talking about is certainly plausible and it has actually happened. What is that? That studies of planetary motions by astronomers had long-term benefits which we enjoy today. Now this is my preposition which I am going to justify as I go further. So let us go back some 200-300 years ago, and there were two important astronomers. One is on the left, that is Tycho Brahe, and on the right is Johannes Kepler. So these two were important people in our argument, and when you see Tycho Brahe on the left hand side of the picture, you will notice, if you take care to look, what you will notice is that his nose has got a very peculiar shape. The nose doesn't seem right. The reason was the following, that Tycho Brahe was a person who did not make friendship with anybody. He always fought with everyone. And one of his acquaintances, whom he maligned, that acquaintance got very angry and he challenged Tycho Brahe to have a duel. In those days, whenever they were fighting or quarreling, sometimes the settlement was done by fighting a duel. So Tycho Brahe had to fight with his acquaintance. And in that process, while they were fighting, his nose got cut. His adversary was better swordsman, and he cut Tycho's nose. After his nose was cut, then his friend or acquaintance said, "Enough is enough. I think I am satisfied that I have taken enough revenge. So you go back and do something for your nose." So in those days, plastic surgery of nose was common, and Tycho Brahe got a knuckly nose, not a real nose, but something that looked like a nose, and that is what you see here. Now, Tycho Brahe was a very good, what you call, observer. So you see here on the right hand side the observatory which Tycho Brahe was the head of, and on the left side you see some big instruments which he used for observing. What you have to remember is that telescope had not been discovered yet. So astronomers were not using telescopes in those days, but these instruments were quite useful in locating objects on the sky. So when Tycho Brahe was very enthusiastic, and when he collected a lot of data, the next thing was, which any astronomer even today has, when he gets a lot of data, then he has to say how to use it. What does the data mean? And that was what Tycho Brahe's problem. Because he saw that in order to get anything out of this observations that he had made, he needed mathematics. And he was afraid of mathematics. He didn't like mathematics and didn't know how to use it. So he advertised for some attendant who will do the mathematical analysis. And this was done by Johannes Kepler. He came and joined Tycho Brahe as his assistant. Now Tycho Brahe, as I told you before, did not make any friends with anybody. He always insulted people. So he insulted Kepler quite often. And anybody else in his place would have left the job and said that you are insulting me, I can't work for you. And that is how it would have ended. But Kepler knew that Tycho Brahe has very good data. So he wanted to know how to analyze that and what does it give me. So he did that, and in the meantime, Tycho Brahe died. When Tycho Brahe died, his what you call the near relations, they came around claiming all kinds of things. They want Tycho had good property. He had an observatory which was very valuable, and he had also a lot of money, had hard cash. So these people wanted to share or claim their part of it. But Kepler was looking at all these things which these descendants of Tycho had come for. They wanted to share his property. But he noticed that they were not interested in Tycho Brahe's data, which was a whole lot of papers stacked together. So nobody wanted it. So Kepler quietly removed it all to his house. And when the relations saw that Radhi had gone out, that is what it was in their eyes, something that had nothing, no use. So they said, better, that was good. Can you hear? Okay. So they said that let it go, we don't mind. And Tycho in fact knew that what he had got was really very valuable. And he analyzed it and found that there were 3 laws of motion of planets, which are very briefly described here. You see here at the bottom, sun at the center, yellow color, and around it is the trajectory, the path followed by a planet. Then the second law says at what rate does the planet move around the sun. It was not a constant rate, but it followed a certain mathematical law which Kepler had derived. And the third was telling us, depending on the distance of the planet, how long it took to go around. So all these things were contained in Tycho's data, and this is what Kepler found. When Newton came around years later, he saw Tycho's data, he saw Kepler's analysis, and he knew the next mathematical step to ask that if the planets are moving according to the orbits which Kepler had found, then what is the reason for it? Why are the planets moving like that? And he found that it was his law of gravitation, which tells you that as you go away from the mass of the sun, you move slowly, and as you come closer, you move faster. So this was the law, the inverse square law that Newton had got. And then there were a lot of other observations which were made by people following Newton, and they found that Newton's laws of motion were correct. So when they did that, in the last century, people began to launch rockets, and they felt that if they had rockets going around the earth, those rockets will follow certain law of motion, and that was the law of motion Kepler had derived and Newton had explained. So you see a connection between the space technology which we enjoy today what does the space technology do? As you see in this picture, there are several usages of space technology. One of which, as I will explain towards the end of my talk on the Chandrayaan, it is an interesting set of rules of how to move in space, which was found by Kepler, Newton, and Tycho Brahe. So we could say that if there were no Tycho Brahe, there would be no Kepler. If there were no Kepler, that Newton would not have been able to get his law of gravitation. If Newton could not get his law of gravitation, today's space technologies would not be able to launch anything because they don't know what is the force. So we would not have been able to enjoy some of the things like when you watch a test match on a TV from a very far away place, or when you also look at Olympic Games, or you observe special occasions, or telephone across the Atlantic or Pacific. All those things are advantages of space technology, and they say that astronomy gifted the law of gravitation, and that is why people are doing all this. So when you say that addition to basic knowledge and use for satisfying energy needs, we can add studies of the sun and stars to the knowledge of controlled nuclear fusion, as I will show you next. So just as you saw that planetary motion is part of astronomy, and that led to space technology and the benefits we enjoy today. In the same way, we can ask about the sun. This is an astronomical question. Why does the sun shine? So, in the 19th century, a solution was offered by Lord Kelvin and Baron Helmholtz. These two scientists you see in the picture, one on the left, one on the right, and you see that their argument was that gravitational energy led sun to shed energy, and that energy comes out in the form of solar energy, solar sunlight. But this turned out to be incorrect. And Eddington, whose picture you see now, he had the correct idea. He felt that in the center of the sun or of any star, usually there is a very high temperature. So here you see the picture of the sun as if it were cut out like a fruit before you, and you see at the center of that sphere there is bright light. That is where the sunlight originated, and it comes out and we see it and receive it today. So the sun has this solar energy, and that is coming from where? So Eddington said that is coming from nuclear fusion. Hydrogen nuclei, 4 of them, when they combine together, they form a helium nucleus. And this nuclear reaction therefore tells us that the energy must balance on both sides. But because nuclear energy is quite high, you also find that in this reaction, lot of energy is extra. When the helium is made from hydrogen, you find that you have some energy left over, and that energy is coming out as solar energy. So today astronomy provides the only working example of the process of steady generation of thermonuclear energy. We know how to produce nuclear bombs. These are explosives and destructive. Here in astronomy we have example of sun, which is using the same reaction but is not allowing it to be destructive. It is a constructive way of producing energy, and that is the example I would like to give as of how astronomy is studying physics to find ways of producing energy like the sun. So, we have to find this answer fairly soon, because as you see in the metropolitan town areas, lot of energy is simply used or wasted, and we must produce sources of energy. So how can we do this? One of them is following the sun and making a thermonuclear reactor. People are working on it but have not yet succeeded. But the other one is, as you see here, in space, you can in principle produce energy by having mirrors, which are concave mirrors, and these mirrors will produce will be pointing towards the sun. They will collect the sunlight and focus it at one point, and if you have a row of these, then you will get a line containing all along very terrible concentration of energy. That can be then converted to microwave and sent to the Earth's surface. And after you have done that, you will produce reservoirs which will convert that back into electrical energy. So this is a space technology project which present engineering ability is enough to make it possible, but it will be very expensive to build. Having all these large mirrors in space, align them properly, will take a lot of effort. But if it is succeeded, then the advantage is that you don't have to spend anything more, because the sun will keep on pouring energy and you don't have to worry where that energy came from. It is coming from the sun. So you will get as much energy as you want, and the energy problem will be gone forever. So we can now come to one last argument which I want to give today to show why astronomy is important. So this is about collisions in space, and I want to give you an example of Shoemaker-Levy, which was a comet which a few years ago collided on Jupiter. And while it did that, it produced a lot of energy around Jupiter. But compared to Jupiter, it is very small, and so there was no problem for Jupiter. But what could happen to Jupiter might have happened to the Earth. And if a comet strikes the Earth, then you will have a lot of problems. There was a comet which came around a few years ago, and it was called Swift-Tuttle. And people made calculation saying that next time it comes close to the Earth, which will be 14th of August, the year is 2126. That is about 100 years from now. Now it suggests that it will strike the Earth. And if it strikes the Earth, there will be disaster almost destroying the life on the earth. So if this is the case, then how are we going to survive? So there were other examples. One is by what you see here in this picture. There is a circular hole which you see in the center of the picture, and that is where some big object had struck the earth. So these are called meteor craters. Meteor is a big massive object which is moving in the solar system, and if it strikes the earth, it will produce a sort of hole there, and it will produce lot of energy. So this particular hole you can find in Lonar Lake. This is a Lonar Lake crater in Buldana district of Maharashtra. So if you are going for sightseeing you go to Ajanta and Ellora very often, this place is not very far from there, and you should go and look at that also, because it is the place where a meteor struck and made a tremendous release of energy. How much was it? So the answer is, in the Hiroshima atomic bomb, the energy release was 13 kiloton. So compared to that, this is about 500 times more. So imagine 500 atom bombs hitting the earth, how much destruction they will produce. Today, of course, we see that whatever happened is now replaced by this lake, because that hole produced source for water to collect, and the Lonar Lake is one example. So asteroidal impact can be more devastating. The bigger the object that is going to strike the earth, the bigger will be the danger. So we can go to, by the way, I should mention that I had written a science fiction story called The Comet, Dhumaketu. It was translated in Bengali also, and it had a hero in the form of an amateur astronomer who is a Bengali. So he discovers a comet, and that comet is supposed to hit the earth. So how to solve that problem, and that science fiction story discusses it, and the same solution was subsequently proposed by NASA, where impacts of this kind were expected. So here you see a 10 kilometer size object would produce an energy of 1 billion Hiroshimas. Hiroshima bomb multiplied by a billion. So that much energy would be produced. So can precautionary measures be taken? So what people are doing are, first of all, looking at such objects in the solar system which are coming rather close to the earth, and sometimes some of them might strike. So if we know such lists, we will be prepared for it. So the conclusion that I want to draw is, astronomy has been and will continue to be an important component of human knowledge base, useful not only for a better understanding of science, but also for the welfare of humanity. So what I would like to end my example, my set of answers to that question, why study astronomy? The answer is, astronomy gives you a lot of interesting information which you would not have got from the earth. It gives you devices which are of space use, which are which otherwise you would not have got. And finally, it might give you valuable information which will save future generations of Earthmen, because we don't know how big the next strike will be. Now, before I end up, I had promised to say something about the Chandrayaan, and I will also tell you another discovery, important discovery which has happened in the last 4 or 5 years. So, the Chandrayaan, as you know, was a creation of Indian space technology. It was a remarkable object, and the project was in many respects quite successful. And they say it is 95% successful, 5% not successful, because what hit the moon did not hit it in a expected way. What was expected was that some part of the Chandrayaan, the vehicle, some part will detach and come down in a smooth way and lie down, so that afterwards the energy from that, signals from that could be analyzed. So that part seems to be in doubt, because there was some kind of disturbance and something did not work, and they are trying to figure out how to improve that scenario so that they can understand what is going on better. Of course, the rest of the project is working well and giving important information. So Chandrayaan is an example of getting energy, not energy but information also. So information about the objects in our solar system. So we had earlier sent a satellite, a spaceship, not satellite, spaceship to the Mars, and now we have sent Chandrayaan. So I am sure more such studies will be made, and we will learn more about the solar system. The second thing I want to tell you very briefly is the discovery of a new kind of a radiation which people earlier did not believe could exist. This was the radiation of gravity. We know gravity is the force which attracts us and which holds all the things on the earth by Earth's attraction. Why the apple fell down on Newton? Because the earth attracted it. So all these discoveries have been there. So the question was, does gravity also communicate through wave motion? Just as you have, if you put a piece of stone into the water, you see that there are things, ripples moving outwards. These are water waves. Similarly, you are seeing light, sunlight or artificial light. All this radiation is also coming from, is a form of wave motion of normal light, electromagnetic. So the question was, does gravity also radiate? And now this has now been possible. The effect is extremely small, but our technology has become good enough to do that. So the next interesting thing from Indian point of view is that India has been asked to form part of a chain of such detectors which are called LIGO, L-I-G-O. So Laser Interferometric Gravity Observatory. So this LIGO observatory, there are 2 of them in America, US. There are something like 3 or 4 in Japan and Europe, and in between there is a big longitude gap where there is no detector. So if we put a detector in India, it will be a very good location for gravity wave measurement. And Indian scientists were asked to take part in this. So the technology-wise, we are able to do, but the question was, will we be able to afford it? Because earlier the Australians had been asked by the same consortium of LIGO operators whether they would have a LIGO type detector in Australia. The technical experts said they would be able to have and they will be happy, but the bureaucrats who give the money, they said we have no money for this project. So Australia withdrew. The Indian government was more forthcoming, and after some persuasion they had agreed to support, and they have agreed now to all the different things that are necessary for it. The land has been allotted. It is going to be near Nanded, which is in Marathwada, which is a part of Maharashtra. And its location is well decided and is supposed to be better than most locations in Europe and in Japan. So we hope to have a very good working instrument I would say 4 to 5 years, because it will take that long to make it. So this is where I am just giving you 2 examples of what astronomy does for us. It is not a remote subject to be only looked by poets who can make beautiful poetry about sun, moon and the sun, but it is a really useful object. So we leave it there, and we will keep coming back as more and more information is revealed. Thank you very much for your attention.
You can see how well Professor Jayant Vishnu Narlikar described the astrophysics and the little bit of theory of astronomy. I hope you enjoyed the video. I enjoyed it a lot. So this is our second video, and we have the one last part, the third part. In the third part of this video, we will see the Bengali version of the speech of our beloved Professor Jayant Vishnu Narlikar by our another beloved person, another beloved Sir Anirban Dasgupta. So that's from now. We give our best wishes to Professor Jayant Vishnu Narlikar, to Professor Mongol Narlikar, and our beloved Professor Anirban Dasgupta, and as well as our beloved science magazine Educate Kishore Bigyani. We all wishes Educate Kishore Bigyani a very, very happy birthday, and we all wishes the best of luck to the magazine Educate Kishore Bigyani. So that's from now. We hope you enjoy the video. Please share this video and give your valuable comment and like this video. We will meet you soon, very soon, of our next video. Till then, goodbye and be well.